Agentic engineering, where AI meets infrastructure.
Hello, everyone. This is AI Native Platform Engineering Podcast. And in today's episode, we are going to talk about securing AI machine learning workflows. And Wojciech will help us to better understand the topic. So, yeah, I guess we can start. Wojciech, the stage is yours.
Thanks. So hi everyone. My name is Wojciech. These are slides I've given as part of my work with ChainGuard, and I'm currently an engineer there. I live in Krakow, Poland. We can skip this slide. So I'll try to explain some of the problems around AI, ML, and containers Kubernetes. I think there's some overlap between AI native platform engineering. It's not 100% aligned, but I think it's an interesting topic anyway. So we'll talk about packaging those, and I'll try to inject some interesting facts about image packaging in general, because I think it is a challenging problem, especially for AI ML world. And I think nowadays it's also running AI ML workloads also touches on some of that. So if we think about a nice slide about what you would expect from containers, you would think about portability, scalability, efficiency, isolation, reproducibility, the main reasons why containers were invented. And it sounds really nice, but it's not entirely true for AI and ML workloads, because if we look at that, it's very, very different from your usual containerized application. Because again, like when you think about just the size of the container, usually containers would be small, minimal, they would have reduced set of dependencies. So basically the less packages, the better. And nowadays the trend is to basically minimize all the containers, like Debian Slim, ChainGuard's Wolfie distribution, a lot of other Linux distributions, like Alpine was one of the first ones that actually focused on minimized container images. But with AI/ML, it's actually the opposite, and it's quite an interesting challenge, because when you think about applications like PyTorch, TensorFlow, I can't even name some of the other ones that we work with back in the days, but they're usually big and they literally ship everything. Sometimes we made jokes that it was half the internet, because PyTorch image would be several gigabytes in size, and that's perfectly normal. And actually, I believe some images are even 10 gigabytes inside, and some of them even more than that, because again, you are shipping an application that ships everything inside of it.
I have a question here, Wojciech, because
Sure.
According to what I remember from the past, I was trying to avoid this issue by using a local storage and cache, which was mounted to Docker containers as a separate process or as another layer. So just avoid putting all this gigabytes into the Docker containers, right? So it's like it's delivered in a separate pipeline as a separate delivery process with use of the storage network, NFS file system, this kind of solutions, EFS when we speak about AWS, but separately from the actual Docker images. Do you have any experience with that approach?
I do. So first of all, great comment, because actually the point here is it's the container image itself. So like you ship enough Python and enough, sample data sets and everything, that image is literally just gigabytes of Python packages, right? Like not just code, but all the training data that you may want to run if you test the image. So it's all there, and it's all those gigabytes. But yes, obviously, if you would be thinking about like a custom PyTorch image with, some pre-built data, then it makes a lot of sense. This is not in the image, but you would use something like EFS in EKS, and then just use the EFS CSI driver to mount it as a volume, right? And then all you would have to do is create a mapping between EFS and the EKS cluster, and then basically mount it in multiple containers. And from my experience, EKS is really amazing. EFS is really amazing, especially if you have a large enough file system, because the speed of EFS disk, just like the network drive, depends on how much data is in there. So if you have like 100 gigabytes of data there, it's actually going to be faster. The IOPS is going to be higher. But in this case, it's sadly not that. It's not the actual data you would be processing. It's just the dependencies, right? The main problem is literally not the dependency health. That's a separate problem for other platforms that some people joke about. But in this case, it's all the dependencies that PyTorch ships. On a side note, like Chingert really has a lot of automation, a lot of AI tooling and everything around building containers. And even with that, we could never get PyTorch with all its dependencies, excluding the NVIDIA dependencies, which also account for a lot of things, to build in less than 3-4 hours, I believe. And then if you include NVIDIA's packages like NCCL, the compiler, and all the CUDA drivers and everything, that takes a few additional hours to build. So there's plenty of things that just go into the image that you wouldn't be mounting. That's not the data. But yes, but if you would be using the PyTorch image in a public cloud, you would obviously want to, especially in AWS in Azure, which do have some reasonable NFS-based file systems, you would be just mounting your actual data this way and not as an image, right? Because with that you can have multiple containers free from that. But no, in this case, it's just the actual dependencies. It's very interesting that it's only that. And again, some of them,
especially when you mount this NFS storage from multiple different pod instances, like 10, 20, maybe even 200, right? In case of Docker images, that would mean you need to Docker pull all of them, all the data 200 times to all pods separately. Well, but in case of the use of the shared network file system, you just need to mount them, right? So that's.
I mean, you would pull it depending on the number of nodes, which gets to another interesting problem, right? Like when we think about small container image and small resource footprint and large amounts of data, like if we would just be using, I don't know, basic Python code, but plowing through gigabytes of videos in 200 pods because you're processing them, what you described would make a lot of sense, right? Because you would be, if you would want to access this as files, you would just be using EFS. In this case, it's also that PyTorch and all the AI/ML pods, they would usually, when they're under load, they would usually be consuming a lot of resources. So you would probably not have 200 pods, right? You would have several pods because they would be using the GPU on the nodes. You would not have 200 nodes for that. It's slightly different workflow, but I agree. Like if you would have something shared, and that, especially if that's your data and not the actual Blaze container, then that makes a lot of sense. Right? Because in this case, which is interesting as well, when you pull the image, it's on your local file system. So for things like Python code in the image, right? That has to be loaded fast for the startup to be reasonable. Right? When you run PyTorch, you actually want to import something and not wait for 10 minutes because EFS has, even if it's fast, it's still relatively slow IOPS wise. Whereas if it's in the image, it's going to be fast. So your data you're processing should be mounted and should be shared. But if it's the actual code, and sadly this is the case in the image, it's like a huge set of SO libraries that need to be read a lot and mapped into memory. Or if it's Python code that needs to get imported, in many cases read as the compiled one as well, that's going to slow down the starting a lot. So that's not easy, but yes. But anyway, this is even one of the problems, and I want to talk about some other ones specific to like AI/ML as well. Like even if we talk about PyTorch, there isn't one PyTorch, or there is PyTorch ships multiple components like Torch Audio, Torch Vision, and Python. Usually we talk about one version of PyTorch itself, latest one, but it has components that may or may not be shipped, and that's one aspect. Then we have the driver support that I think into 2026 NVIDIA finally fixed. This slide is a few months old, but I gave the talk at Rejects a few months ago. But nowadays with NVIDIA's compat layer, it's a bit better. But in the past, you would have to build against specific NVIDIA drivers, because if you have a GPU on the node, that GPU would have specific drivers on the host, and those drivers used to have to match the drivers inside the container, because otherwise they would just not be able to talk to each other. That's one aspect of the combinatorial explosion of all the dependencies. Python. Like there's currently, I believe, 4 or 5 supported versions of Python from 3.9 to 3.14. And some customers.
What about Python distributions like Anaconda, for example? Because
I mean, Chingar doesn't. I believe we don't. I'm not sure what the image ships now, but I believe we wouldn't be shipping. I mean, Anaconda is just one of the distributions. It's also a way to install dependencies, right?
So it's not only about Python versions, but it's also about a couple of different distros of Python, I believe,
I mean,
right?
if we take
Anaconda is the most popular example, I guess, but there's more than this.
right, I mean, yes, because it's also interesting because these tools basically exist for all of the more complex applications like Python, right? Because if you're writing your Python Hello World application, now you would just do pip install, right? The main reason you need Anaconda is because you need an aligned set of dependencies to match, right? So, and then if you use PyTorch as part of your larger application, that's even more complex, right? So in this case, it's like I said, it's not only Python, it's about the dependencies. I believe the chain guard images don't use Anaconda. I don't really remember it right now. I think we decided to just use plain Python and then pip install some of the things, or I mean, use pip to install the things, and chain guard has its own library offering, which is a set of Python packages or many language packages pre-built by Chinga, but that's a separate story. But yes, you would also be using multiple package management systems, right? And at the end of the day, Anaconda is a distribution and a package management handling. But I think the more interesting bits are the GPU and CPU and the drivers. I think it's a tandem, right? So again, if you buy specific hardware like the specific GPU, that comes with set of driver versions that are supported. These days, compatibility layers allow using newer drivers in the container than the drivers on the host, but not vice versa. So it's still a problem, just smaller than that. And also GPU, again, that comes down to drivers, but also testing this against specific GPUs is challenging because you can't always have all the variants of GPUs and you don't have all of them in the clouds. For some people having data centers, you can't really test against all the GPUs they may have because they may have some older GPU version and you may not even have a way to test it properly, unless you actually ship the image and ask the customer to test it. But CPU is interesting as well. And I think, again, some of the things that got slightly better since when I originally made the slides. But the funny thing is, between ARM, NVIDIA, and specific versions of GCC, there was a lot of drama around ARM's features of atomics, which is handling of stack protection, I believe, which was about making sure that the stack gets protected between threads and something like this. I don't remember. It was very problematic because not all NVIDIA drivers support all the GCC versions, and the GCC have to be basically compiled with specific flags. So it's also challenging if you happen to be shipping your own GCC. There was some include files that I believe we also shipped. I don't know if we still do. But basically, if you Google a very specific problem around floating integers with NVIDIA CUDA drivers 12.3 or something like this, which we spent a lot of time fighting, basically ARM had a lot of interesting problems. I'm hoping they were solved over time, but the hack was to basically put a few files in USR include and be on your way because there was no way to backward some of the fixes into GCC because multiple things. But basically, there's a lot of problems with compiling even all of these things because of that. It's very low level, so it's a lot of challenges around that. And again, if you need to support like 100 different variants of that and 10 of them break, you need to figure out solutions to that. So I think before we go further, like I wanted to show this. So this is what AI assumes a container with AI ML application looks like. And I think it's quite accurate because it is a fully bloated container with some things going outside of the container space, like the host drivers and everything. I think it's a very good approximation of all the problems with that. And we can talk for a bit about zero CVs and all the challenges there, and especially in the context of AI ML. But like this is a very interesting problem in general. So the size, right? So one of the interesting problems with these kinds of images, again, I mentioned 5 GB, and I remembered properly. the chain-guard image is 5 gigabytes. If you try to pull the upstream PyTorch image, or that was at least the case a few months ago, maybe that got better now or worse, I don't know. It used to be 12 gigabytes, right? And again, this is just PyTorch and all its dependencies and all of the things that go all the way from 100,000 different Python packages to all the NVIDIA things you will need, including the compilers from NVIDIA GCC, include files, everything that has to be there with PyTorch so that you can compile your things for your GPU. So it's a lot of things. And like one of the things that Chingers had to do at this point was figure out what do you ship, what do you not ship. And like this meme says, you can't just basically disable everything and claim we have a smaller image. So there were a lot of discussions about, okay, how do we know what should be in the images or not? And I believe in the end of the day, we kept Torch Audio, Torch Vision, and the Fluid one for videos, but some of the less popular components went away just because one of Chinger's obsession is getting the images to a smaller size. But that's also true for most images. I mean, I'm focusing on PyTorch here, and I'm happy to take questions on some of the things around PyTorch. It's been a while since I last touched that image. But this is also the case for a lot of other applications. And some of the images I've seen, they basically embedded PyTorch in some other tools and then had some other AI/ML tools on top of it. So I remember there was an image where it was almost 30 gigabytes of just dependencies with dependencies with dependencies. So it's really interesting in this space. And I think what Golang did, where it strips all the unnecessary code automatically, like if there would be an equivalent of that, that would make these images smaller by just not shipping some of the Python code or some of the dependencies that were just included as part of a large set of dependency tree, but wouldn't never get used by the code. That would be amazing. But because of Python's nature, probably that is not possible, right? So with that, yeah, forgot.
Just to have a quick check about the size of the PyTorch image. So I checked on Docker Hub, and the Devel one has 6.5 gigs size currently.
So it got better. Chinger's one had 5 when the upstream had 12. Maybe, like I said, these slides are a few months old, and when I was doing all of the checks there, it was around 12 gigabytes.
No, I'm not saying that's like, I'm just saying that we updated the info is 6.5. It's still bigger than Chenger too, but not that different.
Okay. Right. So, but it's still it's still over 5 gigabytes, right? Whatever the number is, it's quite large. And like I said, there are some apps where they would be simply shipping the PyTorch as a dependency, so it would be getting much more than those 5 gigabytes. And it really goes against the first slide that we talked about, where your ideal container would be a very small distro-less set of files, like just the CA certificates, some basic libraries if you use Seago, and nothing else, right? Whereas here it's 5 gigabytes. Even for a relatively small Python application, you just need Python, some libraries, and that's it. But in this case, it is a nightmare. But yes, it's not something we've solved, and I hope something that the community will be solving or improving over time. Like there's probably some things that will be at least stripped down, or maybe some package maintainers could try to get some packages to be smaller. But it's an interesting challenge. I think it's a common thing with all the ecosystems. Like it's a well-known problem in Node.js as well. It's just that AI/ML is basically shipping everything inside because of the complexity, number of complex things you can do with it, right? So with that, we get to the interesting problem that Chengard has always been trying to solve, and which is, when you think about small images, one of the upsides of if you just ship your Go binary, as long as you update all of your Go modules, you should be all the way to 0 CVEs, right? But then if you ship a large number of software, whether that's dependencies, applications, or anything else, you basically accumulate CVEs because even if you get the latest PyTorch, you get the latest Python, you have the latest glibc, you have all the latest system packages. If you have 8 or 10 layers of recursive dependencies, it's very difficult to update all of them and make sure that your very complex application like PyTorch continues to work and continues to behave in the same way with very different edge cases that people may be doing. And even like going back to some weirder examples, we've talked to some people where they had to, I don't know, pin specific packages to specific versions because their code depended on a feature in an older version of some package, or like same with Python versions. Like Python 3.12 dropped some packages that people may still need. So as long as there are older version streams of Python still maintained, it's fine. But then if you have to pin your version of Python to something old and potentially no longer released, that's a huge problem. And I kid you not, like in one of the cases, I don't know if this was PyTorch or not, the upstream image had over 1,000 CVs, and by removing some of the things we shipped, or by updating all the system packages and everything, we got it down to 0. It could be that the scanner also didn't detect some of the dependencies, but it reported a huge amount of Python packages. So it was there. I don't know if everything was there, but it was there. It just
to summarize, when I decide to use ChainGuard Docker images, that means that they are going to be smaller than the community-driven images, and
yes.
far more secure, right? So I have like two benefits, not only one.
Yes. So basically, a very good comment, right? So basically, ChainGuard does, and I'm quite sure there's more slides on this later, because well, we can drill into that then. So what ChainGuard is doing differently from most images, and we can start with what the second bullet says here, right? So ChainGuard has its own Linux distribution called Wolfie, which is a distro-less distribution, which means it doesn't have a point-in-time releases like Ubuntu or Alpine, where you would have Ubuntu 24.04, and that's the latest long-term release, long-term support release of Ubuntu, which means most images would be based on something that's 21 months old now. What Wolfie does, it's always shipping the latest versions of all the packages, and they are just tested as a set in all the images, right? So we'd be getting the latest glibc released at this point in time, so probably something that was released a few days ago. It's using APKs as the package management, but it's using glibc, so this is what makes it slightly different from Alpine, because also Alpine also has point-in-time releases, but it's also not using glibc, it's using Muscle, which in many cases is somewhat slower. So if you're running a server application using glibc makes more sense. And for most packages, what ChainGuard is doing, it's updating them up to 24 hours after they release. So if we think about, again, like Piotr, you mentioned smaller images, right? So if you think about an image that ships OpenSSL, which is bread and butter for all the applications today, if you use an OpenSSL patched by Ubuntu or maintained by Ubuntu, but the actual upstream version is 21 months old, that means Ubuntu is going to decide, canonical or maintainers are going to decide which vulnerabilities need patching, we need their patches backported into OpenSSL, or which ones are not really applicable, and they would just mark them as won't fix or false positive, or whatever the advisories would be saying, the security advisories. But you would still get that, and you would still get some scans that say this image has these CVs, but they were just marked by the vendor as not applicable. Whereas because ChainGuard is always picking up the latest version of OpenSSL, whenever there's a security issue, that obviously gets fixed in the latest release of glibc. So this way, sorry, OpenSSL. So this way, ChainGuard doesn't maintain a set of patches that have to be applied, tested, that they could go wrong if the version streams divert too much. So ChainGuard is just basically picking up the latest versions, which is why there's less CVs. That's the second thing you mentioned. The first one is like ChainGuard's main goal is to try to ship as little packages as possible with the image. So like I said, we removed some of the packages around PyTorch that didn't reduce its functionality. But still, like when we think about CVs, it's a lot of problems when the application's large, right? So that's not there is no silver bullet for this. There is no single solution to any of that. It's just a problem that I think the community as a whole is struggling with. And I even had a conversation with someone. Someone approached me, and I wanted to ask me about the open source projects that would be trying to solve that problem specifically, right? And I think the outcome of that, and this was actually not AIML, but this was for Python. And the problem that person had is they needed to ship images with all the supported version streams of Python, so everything from 3.9 to 3.14. And there really isn't any open source or fully free set of images or project that would try to solve this problem by building all these images, especially with hardened settings with very small set of packages. And obviously that's because there is also a lot of commercial companies providing this. But I think as a community it would also be just and Wolfie being open source solves some of that, but it would be interesting to see more open source activity in this area specifically. I just think it's a very difficult area to be in with all the commercial competitors. So there's an interesting problem here. As someone working for a company solving this problem, I'm happy with doing this, but it will also be interesting to see more open source activity there, and maybe with the whole discussions around sovereignty in Europe, the open desk images that the German government is providing, there may also be some interesting initiatives in that area, right? Because I believe OpenDesk is also about providing hardened images as open images, especially targeting the European workloads. So
since we speak about European distros, do you have any opinion on the Gardener Linux distro from SAP?
I have not looked at it, to be honest. Like I said, I as an open source passionate, I would always welcome more and more free solutions, so that, for example, if I want to package something, I would always be able to choose. I'm happy that Chingar is doing some of the images as open source and a lot of the packages and the distribution itself as open source. But no, I haven't looked at Gardener yet. So I think that will be something I should do as well.
I want to give it a try because it seems to have similar. It seems to be targeting similar problems as Wolfie.
If it's also distroless, I would really want to take a closer look at this. Like, I think this idea of moving away from like 24 months LTS release cycles, at least for containers, like it's a very good thing to be doing. And I think between some of the Linux distributions out there and people and all of the communities they've built out, there's a lot of people that could be contributing some of their time to something like this, right? Especially if something is automated. And honestly, even like at Chinguard, we're doing a lot of AI-based automation of these packages. Like, this is not what this presentation is about, but we can digress because it's a good conversation. Like, comparing to a few years ago, where most of the updates of definitions of a package were done by humans, right? So when you think about a system package in any Linux distribution, what needs to happen is you need to take the upstream source code, either in like the actual source code, so git clone, or in some tarball that you're downloading and verifying its integrity, right? From that, you have to have some definitions of how to build it for, say, Debian/Ubuntu or RPM or APK, etc., etc. A lot of that used to be done by humans, so you had to have a huge community of maintainers of packages just to keep them updated, right? And I'm hoping that a few years from now, and this is where, I don't know, EU funding, AI, and passionates of AI/ML could come in and try to at least help with like majority of updates being automated. So when you first package, I don't know, Postgres, right? You were at Postgres 14, you wrote how do you build the OpenDesk Postgres package or the SAP Gardener package for Postgres once. And as long as the changes in Postgres are not really critical breaking, or you don't have to pass 20 different new flags to the configure script, then AI should be able, by reading change logs and reading the, I don't know, other existing examples of how to deploy Postgres 15, like AI could be given some ways to test Postgres, could be given some ways to build the package, and could just be iterating on that in some relatively safe sandbox for the majority of things. And I think this may drive some of the wider building of distributions, right? Because you don't always have to have a commercial backer of those distributions.
This is definitely the future, and I have to say that I was really impressed by the interview between Spotify CTO, can't remember the name, with Kelsey Hightower, discussing 40,000 upgrades in production a day, including all Java libs, all binary artifacts, OS images, and so on, right? Including Docker images, Helm charts, and so on, all right? So 40,000 upgrades a day in production can be a manual process anymore, right? And thanks to that level of automation, I think they may have, the most secure infra today in the world, right? When it comes to the dependency management and artifact management.
Right, and I think, like, again, we're digressing from the slides, but that is exactly the point of this meeting, right? We don't have to go through them. Like when we discussed the distroless, all the latest packages, one of the things that I've seen a lot across all of my history in IT is ChainGuard may be providing images 24 hours after something gets released, but like you said, unless the team, the company, the organization running these workloads is willing to spend the next 24 hours or less to update them, you're always going to be running software out of date and you're always going to be vulnerable, right? Because it shouldn't work this way that whenever the next heartbleed happens, everyone panics and starts updating their containers so that they have a newer version of OpenSSL. What should be happening is exactly like you said, like at every single level of your pipelines. So say you just ingest a vendor that may happen to be ChainGuard, but any vendor's container images, as long as they keep shipping them fresh images out of the oven whenever there is a vulnerability out there, you should also be able to consume them as fast as possible. And you should, like, I don't know, deploy them to non-production, deploy them as canary, or do something that you can test them to get enough confidence that they could be deployed to production and they should be there, right? And it's the same thing like you said, like if you use third-party Helm charts, operators, whatever else, like in the perfect world, everyone should be able to do this, right? And then the same with dependencies, you should have tools in place and automation in place that your code base has tests. You can run update, you can tell AI, update as much as possible as long as these tests pass, and then that will get your CVs at least from 1,000 to 10, right? But then you need to have tests, you need to have all the preparations in place, and you also need to have a way for AI to spin up ephemeral, I don't know, VMs or anything like that environment so that you can test your application, right? That's a big problem because if you're doing a single microservice, it's easy. But if you're building like a stateful application, like a database that has 20 different components in it, then you need to have a way to test every single component and test the updates of components in tandem. That's just a lot of problems, right? There isn't anything that is going to solve it. I think AI is going to make a lot of these problems easier. Again, with the right tools, with the right feedback to AI, where you can tell AI, go crazy, experiment with all the things you can think of, and here's a way how you can tell if this is better or worse by giving it some scoring system. It's going to get that right.
But we need to be aware that the bad guys are also using AI today, right? So whenever there is some, annual CV found, it's just a matter of minutes or hours for the exploits to be created and used, right? So the speed of the bad guys is also far different to what we know from the history.
Correct. Although I think the speed of bad guys has always been pretty fast, right? I mean, AI has made it slightly faster, but I've always had the impression that people who had access to, well, not necessarily zero days, but people that would be reverse engineering the patches as soon as they became public, they have always been on this side of the fence where they would be much faster at figuring out exploits for the bugs, much faster than people would be fixing them in production, right? Because what would usually happen, and this is still the case with most things, like you would get some CV announced that there is a critical vulnerability in something as important as OpenSSL. Like when Heartbleed originally happened, you would know about the CV a few days in advance. A lot of people would know when a fix would be released, right? So you would know when exactly to expect it. And then as soon as the fix was released, you could literally git diff the change and figure out, okay, if this is patching this thing, then this is probably how you can exploit the original code version. And that's what a lot of people did. They were quite fast at it. Like it took them usually a few hours, and then you would have automated tools going on the internet and trying to find apps with all their OpenSSL out there, right? So that was always the case. And I think AI will help the good guys more than the bad guys, because the bad guys have always been really good at their game. Like there are going to be more bad guys because it's going to be easier to use the tools. But I think even if you were not a state actor, if you were just someone that was a part of a really good organization, you would just reverse engineer the patches. You would figure out what's the common mistake people do. And as an example of something that I remember was hugely tragic to a lot of people, I remember when MongoDB and a lot of distributions of MongoDB, including the Bitnami one, when I was back in Bitnami, had this issue that by default it had no password because it was assumed that nobody would be insane enough to spin up a VM in the cloud and open the 27017 port. But guess what? Enough people did that people wrote bots that just crawled the whole internet, jumped into MongoDB, encrypted all the data, and left a message like, pay this amount of Bitcoin if you want your data unencrypted again, right? Which means, bad guys have always been that good. You have to be really smart to be the first one to figure out that you can actually automate this and you can actually blackmail people this way and exploit some money this way.
Yeah. But what you are saying is actually changing the whole concept of building the infrastructure, because if I want to my infrastructure to be always up to date for all components, Kubernetes, Docker, all the middleware components, ingress controller, external secret operator, crossplane, whatever I use in my infrastructure, right? That means that while building the infrastructure, I need to build continuous delivery pipelines, updating all of these components on the fly, on a daily basis at least, right? To be always up to date with use of a secure artifact repository like ChainGuard, maybe some other repos, maybe the public ones from the community. But I need to build a pipeline upgrading all of these components on the fly, because what I know from the past is like, we deploy the infrastructure, right? We deploy a number of tools, number of, middleware components, and then we forget about them, right? Okay, there is some sort of upgrade process in place, like every 3 months or every year. The team is, looking, into the outdated components and trying to upgrade them. But this is more like a reactive approach. A proactive approach would be to set up proper continuous integration, continuous delivery pipelines just after these components are deployed.
Exactly, right? So, and a lot of companies don't really do this and don't have plans to be thinking about this, right? So, and again, a lot of companies also don't have the tests, right? Because you mentioned automation. Like, it is not like, if you would be confident that your CI/CD pipelines can catch, detect, test, and prevent them from reaching all the way to production, because there's plenty of ways to solve this problem, you could build automations that, I don't know, wherever you could take your images from, it doesn't have to be ChainGuard, it could even be upstream if they are updating frequently enough. You would just write a tool that basically pulls the latest tags, expands them, and figures out, okay, I need to update from 1801 to 1802, and that's a pull request, right? And then you could have it that if you update and you have a Docker file there, you could have some unit tests that verify the Docker file, like integration tests that verify this Docker image builds, this Docker image starts, this Docker image does some basic things. Then you could have your non-production environments, dev, staging, or whatever you call them, that this gets deployed to, and if they pass, you go all the way from there to production. There's also a lot of tools that allow you to gather all the metadata, to be like control gates, to be like a place where you can decide these things. Or you could just be using Kubernetes for this, right? I mean, using Flux, Argo CD, and any of these tools. Like in Argo CD, part of the deployment could be an Argo workflow that could be running the test. And then because it's part of the deployment, you can see if that worked or not. And that is back into the custom resource metadata. You can just query the status. You can see what's happening. You can determine, is this safe to roll up to the next phase, so like production. So there's plenty of things, but the problem is not enough people build their tooling all the way to support this, right? And this is something we as the community of IT people should be talking more about, because yes, it's convenient not to build, it's convenient to build all the nice cool features, but the next time hardly it happens, everyone has to stop everything else and start running and fixing things. And that shouldn't be how your work is.
Yeah, I mean, all points are valid, but one thing that I will come back to is you're saying about supply chain. So I think there is a lack of proper supply chain secure repositories that actually are trusted fully. And you say upstream and packages and newest version, and that's all cool. But how do you know they are not being taken over? It happened a lot of time already, and that way, I think there is only one way forward. Just like talking about sovereignty, so some kind of like repository that's being actually maintained by paid people, open source, but maintained by paid people, that can be fully trusted. Same like we do with certificates, for example. So,
Right.
and then you can actually make sure that, okay, I have this package from this source, then that means I have, let's say, 95% that it's all good, right? Not 70% like pulling it from some GitHub account that potentially was taken over by somebody else and just switched versions and stuff.
It's kind of interesting, right? Because I haven't used this tool myself, but I know Chingard uses it a lot, and it's open source, right? There is a tool that Chingard has developed called Malcontent, which is doing something really interesting because it's trying to figure out context, differential analysis, and a lot of other things and rules to figure out between version and version, what is the chance that this is injecting something else, that the changelog is saying something else that you would expect. And for example, I don't remember the exact logic here. I've heard about it some months ago. It's actually trying to figure out system calls. It's trying to do a lot of things around analyzing different sorts of attack. Yes, the libxz attack, for example, I don't know if this would discover something as well planned out as the libxz attack, but for some of the attacks where you would have very basic injection of, I don't know, of like crypto extraction or crypto mining, and you would just inject doing HTTP requests, even if it's base 64 encoded, there's a good chance this would detect it, right? And I think that's not solving all the things, but it's also like, what can you do, how much can you do, and when does it become too much? But there's tools like that. There's a lot of things that could happen, but you're right. The problem is if you put enough automation in place, a human can no longer be the gatekeeper and can no longer be making all the decisions themselves. And that's where you also need automation.
But we need to balance the risk of introducing a change, introducing a new version of the component, keeping the old one running for longer, potentially containing some kind of security related issues, right? So I think this is like combining two different metrics. One metric which is representing the risk of introducing a new change, the risk of updating the component, which is X, and another metric which is about keeping the old version of the component running for longer, for days, for weeks, for months, which is also potentially related to some outdated packages, including CVEs and so on, right? So which is Y. So these two parameters to be compared, and then we can decide, okay, does it make sense to upgrade or not?
Yes, and
because for example, layout changes, right? Front-end layout changes, which make no any change for actually the way the application operates, right? So front-end interfaces being updated. They change the color from red to green, right? So the value of upgrading just for this single reason makes no any
well,
actually...
I mean, Piotr, you may be right here, but imagine like there is version 1.0.0 that is red, 1.0.1 that is green, and suddenly there is a version 1.0.2 that has a vulnerability fixed, right?
Yeah.
And
right.
You can always be like 20 versions behind because neither of them gave you any change, but suddenly you're testing and analyzing the risk of 20 different versions, right? Whereas, like you said, if you keep on updating all the time, there is this small risk that someone will open an issue, hey, this color changed from red to green, change it back. And then a human has to go in and figure out, do we change it back? Do we explain it? Do we document it? What do we do? Because maybe internally that color matters because we applied a CSS change. And that, that could be a valid reason. If you changed your title of a tool to be red and yellow, but the upstream application changed their title, the text in that title to be red as well, then surprise you don't no longer see the title.
Yeah.
It's actually a valid issue for your company, but it wasn't a valid issue to bump it to a major or minor version change for the upstream. So there's always things like that. But I think whenever you make that first decision that I'm going to stop upgrading because there is no reason to upgrade, you're going to get caught by a security fix that is, now suddenly 30 versions ahead of you, and what's the
So
risk
it's
of
also
that?
about the readiness for the future changes, right?
Exactly.
Yeah, I would call it this way, just readiness for the future updates.
Yes, and I am going to suggest, because we probably should be wrapping up soon, I'm going to quickly go through the slides and see if there's anything interesting we can talk about. Right, so I think we talked about going about this in more depth, about versions, packages, and like the packages in there. We talked about this GPUs. Well, one thing I didn't mention about PyTorch and a lot of applications around AI/ML. TensorFlow, I think, has this issue as well. The code for GPU and CPU support is very different. So testing them without GPU means you're actually not testing the code base. You have to be running an automated test, which go back to the confidence discussion we had on something that has a GPU to be 100% sure they work, right? So if you took upstream PyTorch, you build some AI/ML workflows. If your CI doesn't have a GPU and you run tests, it doesn't mean your image will work in a GPU-based environment, which is really interesting. Obviously, it may not work either because of NVIDIA drivers or something else, but having very similar environments when you're actually testing the images is critical to the CI. And testing, yes, I mentioned that, using GPU's performance. Oh, this is something that was interesting. I know there was something really interesting at the end. When working with these images, and that wasn't something I contributed, but we were playing with the performance and comparing upstream to our image, and we found that in some case we used VNF, and for some reason, probably more IO operations or something, in some AI workloads were actually slower. They were like 10% slower, which is not a lot, but if you're running expensive GPU workloads, 10% may accumulate a lot of money on your monthly cloud bill. So one of the interesting things was we ran into the VNF problem, and I know we reverted from using VNF to just installing the packages in /usrlib for performance reasons. I know afterwards someone looked into going back to VNF. I don't know what the status is right now. Maybe we actually found the root cause because not using VNF was more of a workaround. With VNF, the nice thing is if we ship PyTorch, but it could also be shipped as a dependency for something else. Without VNF, it's injected into the main Python packages. But yes, that was, I think, the last PyTorch AI/ML specific thing in here. We have a few more minutes to do some discussions if you want.
Yeah, so did ChainGuard have any proper testing platform based on cloud? So did you run, for example, something like I don't know, hundreds of thousands of tests on a cloud daily basis, or you just, as you say, put it out there and clients run them?
We struggle with testing all the things, and again, I've been out of the picture for the AI/ML images for a few months, so maybe that got better. I think with all the images and all the companies building images, even teams building their own images, the problem is you don't, like, when you're writing your own software and you're writing, I don't know, a database, you would have a lot of unit tests, you would have a lot of integration tests, and a lot of other things to test these features at the code level, but you don't often have all the tests, the equivalent of this amount of tests for image levels. At ChainGuard, one of the things we started doing ever since I joined ChainGuard, I was one of the advocates for this as well, but I think the whole company understood this. It was just a matter of prioritizing this properly. We started adding more and more tests every single month, so more things are automated these days, including, I don't know, like Kubernetes operators would actually run in Kubernetes. This would actually be run in GPU, in VMs with GPU, using some sort of Kubernetes clusters. It's not doesn't necessarily mean that it gets run against all the versions of EKS, all the versions of GKE, all the versions of AKS, especially that sometimes it's very difficult to get all of these across. But the images were run against, I believe, 2 clouds, if not 3 of them. Maybe now it's all 3 of them, but it will run against two of the clouds, excluding the clouds that's also like run by a company also doing an OS that Piotr knows about. So, but more seriously, they were tested. They've tested across Intel and ARM. They are tested in Kubernetes-based setup. It's just doing, like you said, doing thousands of tests when you release these images every few days is close to impossible. So some of these things happen semi-manually, like there would be scripts you run, but someone will have to go and run them whenever major refactorings happen or something like this, where you would try to run more benchmark-related tests, more tests related to, I don't know, edge cases, right? But what does run all the time is things like, does this start with a GPU, without a GPU? Does it start on Intel? Does it start on ARM? In some cases, this means you have to actually spin up a pretty large VM with GPU just to basically run a hello world test to make sure it loads. But that's, that's something you do as part of these, providing these images. And it's a
what comes to my mind while we speak about this topic is to follow the same approaches, like on my MacBook and MacBook OS, where I can flag my operating system to send reports to the Apple developers just after the incident or an issue occurs in my laptop, right? So kind of a system collecting the data from the environment, from inside of the environments of your customers. So assuming they allow you to deploy it, right? So we can deploy an agent monitoring, how the images from ChainGuard operate in this particular environment. I don't know, Alibaba or some, very specific cloud, very specific Kubernetes version of, and so on, and sending some sort of reports or metrics to ChainGuard related to the stability of the artifacts.
Yes, and I mean, it's, it would be nice to have something like this as a very generic solution. In reality, there isn't a single universal tool to debug things. But yes, I think a lot of customers that would have a lot of experience with these kinds of problems, because we may not be the only ones providing the software, etc. Or they may also be using commercial software where they have a support contract in place. Well, obviously we also provide support, but I mean, like if someone actually has a contract with, I don't know, with a commercial vendor providing with images, they would have tools in place to collect the logs, but usually it's not as fancy as this. It's usually sales engineering working with the customer to reproduce it in some environment that could then be shared with engineers, and engineers getting like an issue with the document on how to reproduce the issue locally is the ideal outcome, right? In some cases, it's like we couldn't reproduce it with the customer, but here are the logs. Maybe this helps, and the customer is willing to test it, right? So sometimes that happens. Sometimes it's a bit in better.
I would say
some customers will be happy to share with you, this kind of data, right? Real time. By installing some sort of Kubernetes operator or whatever, an agent monitoring all the artifacts from ChainGuard and how they behave.
Yes, but I think usually they are not just used as ChainGuard. Sometimes you would pick up a base image from ChainGuard, same as you would use any other base image, and build your application on top of it. And then that's very different story. Who going through would be the one fixing it, right? So if you use, because then it's a very mixed responsibility. If you take a Python image that ships some packages, and then you would add your application on top with some other packages, if there's an issue with that artifact, who should be the one looking at this as well, right? But if you're only shipping like a Postgres image or a MongoDB image or any other application without any changes, and just use that, then it probably makes sense. But we don't have any tool like that because not everyone runs Kubernetes either. I wish everyone would, but some people run other things. Plus, I mean, some people also run other solutions like Google Cloud Run, right? Our images work fine with Google Cloud Run. So why wouldn't you run it then? And then it's a very different set of troubleshooting. It's actually more difficult to troubleshoot Google Cloud Run than Kubernetes. But the upside is you only pay for the compute that you use, right? So there's ups and downs of every technology. That's why there also isn't a single tool to troubleshoot everything and a single way to deploy images. And we don't test them in Google Cloud Run on a daily basis, but people use it. We use Google Cloud Run for some things, and it's a very perfectly valid way user images as well, right? You could
Okay,
take our Python package, build something on top of it, and boom, send it to Google Cloud Run.
One more question from my side, perhaps a stupid one. I noticed recently that when installing the LLM frameworks like VLLM, LLMD, you can pull the models from the internet, right? Like Olama, DeepSeek, the French one, forgot the name, M something. Mistral, exactly. So you can pull the models from the internet. Wojtek, are you also going to support the models, or just the frameworks around it, like PyTorch you mentioned before? Because the models could be also an option, to.
That's probably more of a product question. I'm not going to properly answer that. But as an engineer and someone who understands some aspects of security, I would say whenever you pull something off the internet, that is your choice and that is your responsibility, whatever that means, right? Because you can always curl pipe bash and whatever base image you use, from now on, it is your problem, right? It's similar here. Like everything you pull can potentially escape the sandboxing, just do everything else. Like I recently had a discussion about SQLite databases. They are reasonably safe to assume that if you pull it, if you open it and not expose any functions to it, they're safe. But what if there is a critical SQLite vulnerability that allows escaping running arbitrary code in the context of your process, right? So you may not escape the container, but you may still be able to export all of the environment variables to your CNC system and capture potentially sensitive data, or capture the database itself and potentially get some I don't know.
Yeah, but models are big, it's about gigabytes, right? It's about gigabytes, so there's a lot of room to to inject some
yes, but I mean
unsafe code.
Right.
Pavel, do you have any opinion on that? Because I believe you are the most experienced guy in this audience with the models and pulling agents and stuff like that.
I don't think it's gonna work like that, meaning that the images is not the best way to distribute models. Just saying, because of the size mostly. There are some smaller ones, but if we are talking about like PyTorch having let's say the 12 gig, the 12 gig for a model is very small. So at this point, distributing something like half a terabyte, for example, for bigger models, or even bigger, I see zero way of doing it properly. And also the fact that this is like a different set of like not principles, but problems that come with it. You can pull like a lot of different models being built by you, whoever, yeah. As Wojtek says, it should be your responsibility fully what you do with this.
All right.
That's my take on it.
Yeah, especially that it's an interesting problem. Like I guess it's when you think about it, it's very similar to Go modules, Python packages, and PM packages, and everything else. You're basically pulling things off the internet, and at some point you have to make a decision whether you're okay pulling them. They're just they're just bigger. But again, like when you're pulling PyTorch, you're pulling 5 gigabytes of code. You're not going to look at all the lines of that code anyway. You're just going to assume that whoever is maintaining PyTorch made the decision on their dependencies, and whatever dependency they use, whoever maintains that package made the same decision, or the PyTorch the community would not have used the package. But in reality, is all of this true? Can someone inject something like the 7th layer of dependencies of PyTorch and get away with it? Probably yes. So there is that.
On the other side, you can have some like semblance of control over this because since models, if you don't give them access to agent sites, so don't have access to tools, they're just there and they do stuff, but it's more or less locally, right? It depends on how you run your stuff, but locally, meaning in your environment. So it's not that big of a deal at this point. It's more like what you do with them with regards of your applications, and then embedding them somewhere else. Not just models themselves are all good. Yeah, if you want just to test them.
No, I'm pretty sure in 2 years, ChainGuard is going to offer, models distro.
I mean, that's why I said they're probably closer to
yeah.
packages, right? Because ChainGuard already has the ChainGuard libraries, which is a solution specifically for like Java, Node, Python packages. I don't know which one. Go doesn't really need that problem to be solved because they have the hashing and everything in there, and they rebuild on your end. But like a lot of the packages, there is no 100% accuracy between what you publish in npm.js being your source code being compiled in a trusted, attested way, right? Whereas Jacob will be doing that. So yeah, I mean, I think same thing may happen where someone will actually make sure that the model that gets published somewhere is the same thing that's somewhere in not the source code version, but like that is a trusted source code. Yeah.
Last question from my side, Wojciech. So let's assume that my team, uses some sort of the PyTorch images and we pull it from ChainGuard. But over the time, we find that our GPU is different, or some particular attribute or flag is not supported, or we use different GCC whatever. Is there a possibility to request ChainGuard or to ask ChainGuard about building a dedicated container for our team, dedicated distro? I believe this is a part of some sort of professional services support, or
I would say yes, and I obviously say that would be something that other parts of ChainGuard outside of engineering would be arranging. But yes, it is quite not regular maybe, but there's a lot of history with ChainGuard providing some customization, some changes specific to a customer or something like this. It doesn't even have to propagate to all the other customers. There's ChainGuard has the technologies to do that. There's even a thing called I forgot the name right now. There is a tool in ChainGuard where you can basically take an image and apply some customizations on top of it by, say, installing other system packages or running some basic commands perhaps as well, or changing like DUID environment variables. So you can do some sort of custom assembly is the name of the tool. Sorry about that, yes. And you can customize the image to some small extent. If you need more customization, there's ways to do this. Yes, but it is a longer story. And, I think, again, I'm not the person that should be presenting this. I'm quite sure if you reach out to someone in sales at ChainGuard, they will tell you the whole story and much more about the images. But then they will also be contacting you a lot, as you know from your past experience with ChainGuard.
Okay. Paweł, any more questions from your side?
I guess so in wrapping up this whole presentation, so how do you think this will go forward? So in general, meaning or we talked about supply chain and different versions and compatibility and so on. But do you think that's basically at some point there will be no need for such customization, or maybe this be some kind of standard? That's what I would hope, at least that some in the future.
I think all ecosystems mature, right, over time, and this is more of a philosophical question than specifically AML at this point. But I remember early days of Ruby on Rails, early days of React.js, and all the frameworks where they would be reinventing themselves, or even Angular, right? Angular kept reinventing itself for at least version 2 and version 4, and now I have no idea what the status is. And React was reinventing itself at least a few times using actions reducers, async, all the things that the Java's ecosystem started adding. Same thing with, again, like Ruby on Rails ages ago. The first versions were very different than, I believe, Rails is at version 7 right now, and now it's much more stable. Golang has been one of the few languages that kept being pretty stable, and Java is now more on the side of let's reinvent a lot of things, whereas it was stable for quite a while. But most ecosystems tend to slow down and become more stable, and this is where things like optimizing, cleaning up, standardizing, and requiring less effort to get there are needed. Given at operating system level, now it's mostly Linux, and a lot of the things are automated. AI knows all the things, so manual system administration, if you choose to do it, is very easy. But back in AIX Solaris days, you would have to figure out which shell do you use between KSH, Bash not being there in a lot of places, DCSH, and all the other shells that you would potentially be using, right? And now that's a solved problem. So I'm thinking it'll get solved, and we will have new applications that are cutting edge. That will be difficult. Kubernetes used to be cutting edge and difficult. Now
Yeah, but we want it to be boring over the next year, right? That's the hope.
I'm sure it will get boring by the time the better technology comes along and it starts being the cool kid on the block, right?
Yeah, because we have other problems to solve, right?
Exactly.
Okay, so I think that was great stuff, Wojciech. I learned a lot. Fingers crossed for ChainGuard. I think it's the biggest inventory of secure binary artifacts today, right? I guess we can close here. So thank you for the presentation, and next week we'll be having another episode. See you.
Thanks, everyone.
Thank you.
Cheers.
Peace.